Hello everybody, I am Magali Picard and welcome back to the complete educational program video proposed by Demptos Corporate in its Design My Barrel offer. Today I will talk in more details about the barrel making process and the reuse of oak cask in the spirit maturation. After the timber selection and the way of cutting the trunk, the main other steps of the barrel making process are firstly the seasoning, which concerns the way of drying wood staves, then the raising, corresponding to the barrel building by aligning with precision the staves with the aid of metal hoops, then the heat treatment, which refers to the toasting and the charring process of the cask, followed by the assembly of heats and the final test to the check of the structural integrity of the cask. And finally, the regeneration for reusing the barrel in spirit maturation. In this video, I will pay more attention about chemical and biological processes occurring during the seasoning and the heating of the oak wood, as well as the impact of the reuse of the spirit chemical composition. So, green wood cannot be used for copperage due to, firstly, a great quantity of water, up to about 70%, the presence of some extractable compounds that are not compatible with the objective of improving the quality of spirits, since there is too many bitter polyphenolic compounds and very few aromatic ones. Thus, seasoning prevents the wood from shrinking after construction and hence barrel leakage. It also appears to be a good way for the wood's maturation, improving the sensory quality of the oak wood. Wood seasoning in copperage usually happens under natural conditions in the open air during a variable time period between 18 and 36 months, depending on the requirements of the copperage and the end users. Seasoning allows reduction of the high percentage of humidity in wood. During this process, oak wood goes through the following phases: dehydratation, rehydratation, and constant humidity, which slow the process, thus reducing the risk of fissures appearing in the staves. Climatic factors involved in the natural seasoning are numerous: rain, wind, sunshine, or temperature variations. Actually, the staves are washed by rainwater and dried by the sun until they have the right level of moisture needed to mold them and give the barrel its characteristic shape. In case of rainfall, only the wood surface is rehydrated. Thus, neither the depth layers of the wood stave nor the staves in the middle of the stack are impacted by height precipitations. The geographical sites where the wood is seasoned does not significantly influence the drying speed. However, the volume of precipitation and its annual distribution condition the feasibility of air drying. This is the reason why in countries not very rainy, drying is not recommended. It would be too fast, leading to significant losses of wood and no release of wood extractives. The ideal conditions are met for oceanic climates and continental climates with oceanic margins. During seasoning, the surface of staves is covered by a fungal flora. Fortunately, the matrix of oak wood, made up of cellulose fibers, hemicellulose and lignin, is composed of phenolic elements which have repressive and inhibitory effects on microorganisms. However, 3 fungi species resist to the wood matrix toxicity. The spores of this microorganism developed mycela that penetrates through microcracks in the wood depth until about 10 mm depth after 12 months of seasoning. They have the ability to resist to high temperatures, above 40 degrees, and quite low hygrometry, between 35 to 65%. And finally, obtain glucose from complex polyphenolic structures. Concerning the elagitanins composition, the seasoning process results in a loss of hydrosoluble polyphenolic substances, such as elagitanins, which could be due to various physical and chemical mechanisms, including, firstly, hydrolytic oxidative degradation, leading to a polymerization of elagitanins. The stave leaching, they are carried out by rainwater. And finally, microbial enzymatic activity, which degrades the elagitanin structure. These different phenomena have a positive impact on the wood quality, since they significantly decrease the concentration of elagitanins, more particularly until 3 years of natural seasoning. Moreover, we observe a reduction of the bitterness sensation thanks to the leaching by rain. In addition, natural seasoning also has a significant effect on the aromatic profile of the wood. During this process, the wood volatile compounds show different behaviors. Eugenol and vanillin, responsible to cloves and vanilla aromas respectively, increase of the seasoning period. This is due to the degradation of their precursor, the lignin, through depolymerization and the degradation of its monomer units. The release of whiskey lactones is possible during the natural seasoning thanks to the enzymatic activity of the bacterial flora. We particularly observe an increase of the cis-isomeric form of the whiskey lactone, while the trans form remains quite stable. Since the cis-whiskey lactone is more aromatic, the wood aroma potential increases with higher intensity of coconut flavors. Moreover, a reduction of oak flavors is obtained during the natural seasoning by decreasing the content of some aldehydes responsible for sourness and herbaceous notes of the green wood, such as octenal and nonenal compounds. Even the natural seasoning presents a lot of advantages for the improvement of wood qualities. The long immobilization time of the wood in the copperage seasoning pork have raised the interest of looking for other alternative seasoning methods. And this is the reason why artificial drying appears as an alternative, more particularly for American copperages. It consists of dehydrating the wood in dry chambers in a shorter time than natural seasoning. Although it is of interest for economic reasons, the artificial of kiln drying doesn't improve the wood quality at the same level that natural seasoning. Indeed, lower content of aroma compounds and higher concentrations of elagitanins are found when artificial drying is applied. The principal effect of kiln drying is the removal of moisture, due to the sterilizing effect of the drying chamber. Thus, the benefits of the microorganism activity are lost, and the impact of the maturation potential of oak wood is significantly lower than seasoning in open air. After assembling the stave during the raising step, the barrel is heated over an open fire in a charcoal pan or brazier. This operation, called toasting, consists of 2 stages. During the first one, called tightening or bending or centrage, the heat of the open fire increases the flexibility of the staves, which allows the winch to bend the staves until they form the characteristic shape of the barrel. The second stage, properly named toasting or bousinage, changes the wood's chemical composition and physical structure. It is an essential phase in the manufacture of high-quality barrels because it mellows the wood's harsh elagitanins, mitigates raw oak flavors, and generates several new aromas that increase the intensity and the complexity of the spirit aging bouquets. There is no industry standard for setting toasting levels, so there may be considerable variability between cooperage. The method of heating may vary from various degrees of intensity used by European cooperage to an intense charring applied by American coopers. Despite the diversity of toasting protocols, The toasting level is usually classified as light, medium, and heavy. Toasting temperature in Demptos copperage generally vary between 110 and 230 degrees, and the toasting length between 20 to 45 minutes. Medium plus, a specific level of medium toasting, also exists. During the toasting process, a variety of pyrolysis reactions take place, producing the degradation of food polymers. Firstly, the degradation of polysaccharides leads to the formation of furanic aldehydes, responsible for caramel and almond nuts. This reaction is favored at high temperature, typically during heavy toasting, and is also catalyzed by the presence of acetic acid in the wood. The thermodegradation of lignin mainly leads to the formation of phenolic aldehydes and volatile phenols. The increase of the temperature intensity leads to the formation of volatile phenols from the degradation of phenolic aldehydes. At too high temperature, between 220 to 230 degrees, the thermal reactivity of lignin decreases, leading to a lower formation of phenolic compounds. Finally, lignin pyrolysis allows the formation at medium and heavy toasting of phenolic ketones, characterized by vanilla nuances. The thermodegradation of lipids and glycosidic compounds also conducts to an increase of whiskey lactans and tabanon. Interestingly, the higher the temperature, the higher content of cis whiskey lactone, and thus the higher aroma potential of oak wood. Finally, the Maillard reaction also produces other volatile substances from polysaccharides, such as pyrazines and pyrols, with various nuances in roasted notes, from pecan nut, licorice, and cocoa beans to coffee and chocolate. The heat treatment also exerts a significant influence on total elagitannine concentration. The higher the toasting level, the lower the total elagitannine concentration. This drastically reduces the astringency sensations. Thus, depending on the intensity level applied on the wood during the toasting step, different kinds of food sensory profiling emerge, leading to specific spirit aging bouquets. Freshness and spicy aromas with a light toasting, with a high impact of elagitannins in the spirit taste and body structure. Complex, sweet, spicy and toasted aromas with a medium toasting, combined with a balance of soft elagitannins. And finally, more roasted, mineral and aromatic aromas with a heavy toasting, with a low levels of elagitannins and thus a small impact in the spirit structure. Finally, the various chemical reactions during the toasting step, combined with the initial sensory properties of the oak species, produces a large range of oak cask possibilities. Either a better expression of the fruity and floral distillate character, or a strong influence of the wood aroma potential. This leads to a large and complementary impact on the spirit aging bouquet. The showering occurs at higher temperatures, above 280 degrees, and refers to the development of a charcoal layer at the stave's surface. The interior of the cask must catch fire for a predetermined amount of time, leading to different wood aspects at the surface of the staves. Showering process has three main effects. The filtration, the creation of the well-known active carbon layer that absorbs undesirable aromatic substances such as sulfur compounds. Then the penetration of the spirit deep inside the wood through the cracks caused by the flame, leading to a more reaction with uncharred oak. And finally, the extraction step, the release of several aromatic molecules during maturation, which is affected by a higher production of volatile phenols and a decrease of whiskey lactones and elagitannins extractive contents. Showering and toasting are not mutually exclusive, since combining these two kinds of heat treatment offers a dual advantage on both surface and deeper in the wood. Actually, the intensity of toasting also impacts the aroma composition of wood in the depth layers. Differences in composition take place through the thickness of the stave, depending upon the thermal stability of various extractive precursors. Then, the application of a charring step on the toasted staves allows the formation of cracks, leading to an increased penetration by the distillate. Recent experiments performed in the Demptos Research Center reveal that the application of a medium toasting following by a charring increasing the aromatic complexity of the oak wood. Depending on the length of charring applied to a medium toast wood staves, there is no same balance of the aroma compounds produced, which directly affect the final sensory wood potential. At wood surface and whatever the oak species considered, French or American oak, applying a short charring, about 1 minute, to a medium toasted oak wood gives a chemical profiling dominated by tabanones and phenolic aldehydes, while a long time charring, about 10 minutes, results in higher concentration of volatile phenols, pyrazines, and pyrols. At wood depth, chemical differences are observed depending both on the oak species and the charring time applied. For example, coconut and vanilla notes are exhausted in deeper layers of the American wood, while roasted compounds are more present in the French oak species. Using the toast and char process, it is possible to generate a singular sensory profiling of the wood both at surface and at depth, thanks to the dual benefits of toasting and charring. So, based on the combination of the oak origin, the toasting and the charring time, this new process offers a large range of diversifying the aromatic potential of the wood cask, which directly acts on the spirit aging typicality. Thus, depending on the maturation time desired for your spirit, short or long maturation, you can choose the better maturation solution to meet a unique sensory profiling. In the spirit industry, and more particularly in the whiskey one, very different traditions are found in the reuse of cask. In general, casks are reused for maturation until the ability to mature the spirit is considered lost by the distiller. It is accepted that the levels of cask extractives decline with the reuse of barrels. Indeed, used casks release lower concentration of most extractives and generally lead to much longer maturation times than found for new casks. This directly impacts the quality and speed of maturation, strongly influenced by this decline. This is particularly the case for aroma compounds initially found in the oak cask, such as vanillin, whiskey lactons and eugenols, but also for elagitannins. This directly affects the sensory impact of cask, with a significant decrease of the both aroma and body structure influence of the wood on the spirit. Studies performed in the Demptos Research Center on roasted aroma compounds produced during the toasting step revealed a significant decrease of the pyrazine and pyrrole content at depth in the wood when the cask is reused compared to a new one. The overall sensory potential of wood is thus reduced, and this has a significant influence on the quality and complexity of the spirit aging bouquet. The decline in cask viability led to the adoption of various methods of regeneration treatments to increase the effect of wood cask on the maturing distillate. More often, this will be a charring procedure, sometimes in conjunction with the scraping out of the exhausted inner layer of wood. This is in favor to release aroma compounds from the deeper layer of the staves through a thermal degradation of polymers at depth, leading to an increase of aroma compounds production. However, products stored in new charred barrels contain congeners originating from the char layer as well as from the wood directly under the char layer. So, with barrel reuse, congener formation occurs less from the char and more from the wood under the char, resulting in lower congener levels in the product. Thus, Although resharing used barrel increased the amounts of material extracted from wood into spirit, it does not perfectly recreate the initial sensory of the wood. So thanks everybody for watching this training video about the role played by the key parameters of the barrel making process. And you can find all this most important information in the Design My Barrel reference handbook. In the next video, I will talk in more details about the multisensory evolution of the spirit over maturation upon wood. So see ya!